Hello everyone, I am Shayani Chatterjee. Welcome you all to my YouTube channel. I am back again with a new civil engineering video. Today we will be solving the first problem of our topic, hydrostatic pressure. So first of all, let us see what is given in the question. A hydraulic press has a ram of 0.2 meter diameter and a plunger of 0.03 meter diameter. It is used for lifting a weight of 30 kN. Find the force required at the plunger. First of all, we will see what is a hydraulic press. A hydraulic press is actually a device which is used for lifting heavy weights by the application of much smaller forces. It is based on Pascal's law. I have drawn this diagram of hydraulic press. When we apply a load on this plunger, it moves down and same amount of fluid will be displaced in this part of the container and same pressure is created on this connecting pipe and the other cylinder also, and as a result the water displaces up on the connecting cylinder. So this part of the hydraulic press is called as plunger and this part is called as ram. So now we will write the given data. So first is the diameter of the ram, that is 0.2 meter. Next is the diameter of plunger of the hydraulic press, which is 0.03 meter. For easy understanding, I am rewriting the diameter of the ram as dr and diameter of plunger as dp. Therefore, now we will find the area of the ram. So area of ram, that is A suffix r equals to pi by 4 into dr square. Dr equals to 0.2. So pi by 4 into 0.2 square equals to 0.0314 meter square. So now we will find the area of the plunger. So area of plunger, that is A suffix p equals to pi by 4 multiplied by dp square. So pi by 4 into 0.03 the whole square comes out to be 7.068 into 10 raised to minus 4 meters squared. And the third given data in the question is the weight. So the weight which is placed above the ram, that is W equals to 30 kilonewton. Now we will convert 30 kilonewton into newtons. So it will be equal to 30 into 10 to the power 3 newton, that is equal to 30,000 newton. So now we will do the solution part. So the pressure intensity developed due to the plunger, and the plunger is placed in the smaller cylinder which you can see in the diagram, and pressure intensity equals to force divided by area. Therefore, the force acting on the ram equals to the pressure intensity multiplied by area of the ram. We all know that intensity of pressure or pressure intensity equals to F by A. So I am replacing P by F by A multiplied by the area of ram. And this will be equal to the force, that is F, multiplied by area of the ram. So we have already found out the area of the ram, that is 0.0314 divided by A. Now this A is nothing but area of the plunger, which is 7.068 multiplied by 10 to the power minus 4. So this AP is nothing but area of plunger. And the unit of force is nothing but Newton. Now this force F is not known to us, so this is unknown. So in this question we are asked to find out this force which is required at the plunger. So the force acting on the ram, which is on the left side cylinder of the hydraulic press, therefore this force is equal to the weight that is lifted, which is equals to 30,000 Newton. So this weight lifted value was already given in the question. Therefore 30,000 is equals to F into 0.0314 divided by 7.068 multiplied by 10 to the power minus 4. Now to find F, we will simply do cross multiplication. Therefore 30,000 multiplied by 7.068 multiplied by 10 to the power minus 4 divided by 0.0314. Now it will be equals to 675.2 Newton. Therefore our answer, that is F, equals to 675.2 Newton. Now let us see the uses of hydraulic press in industry. Hydraulic press is used in the manufacture of car parts and several other parts of automobiles. Hydraulic press is also used in military applications. They are used where loading shells and other ammunition-related tasks are involved. Hydraulic press is used in the manufacture of electrical equipments and electrical parts during any major electrical installations. Thank you all for watching this video. Please subscribe to my YouTube channel. Please like this video and share it with your friends. Meet you all soon in a new civil engineering video.